All right, so now that we've explored the relationship between velocity and position and distance and velocity, I want us to get a little bit more into average velocity because these are the concepts that will directly lead us to the concept of the derivative. So let's talk about that problem that is in well, that was in one of your classwork sheets. And there was the problem with Veronica. So Veronica did a slope walk in front of the motion detector, and she ended up with this graph. So it looked something like this. So here was her time in seconds, and here was her distance in meters. And she was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then she was at 1, 2, 3, 4. And then she started out over here. And here, and then she decreased in distance, started walking back to the motion detector, and then started walking away again, and then stops walking a little bit. Okay, so there were a few questions involving her distance time graph that you were supposed to answer. So the first question was, how much time did it take? Okay, so as you can see, she took about from 0 to 13 seconds. So let's say 13 seconds. Next, how far did she travel overall? So she started out at about 0.75 meters away from the motion detector, and then she walked up to 2 meters. So that's a distance of about 1.25 meters. And then she stopped walking for a bit, so she traveled no distance. And then she walked back to the motion detector about until 0.5. So she walked another distance of 0.5 meters. Then she walked away from the motion detector, and she walked a distance of about, let's say from 3.5, from 0.5 to 3.5, so about 3 meters. And then she stopped walking once again. She didn't really travel much distance. So in total, she traveled 1.25 meters plus 0 meters. She didn't travel at all. Plus a 0.5 meters back to the motion detector. Then another 3 meters away from the motion detector. And then 0 meters at the end there. So in total, she walked 4.5 meters. Okay? So distance is always positive, right? So even though she was walking back to the motion detector, that negative is a direction, not the amount of distance she traveled. Okay, next. The third question was, how far from your starting place did she end up? So she started at about 0.75. She ended at 3.5 meters. So she traveled around, so 3.5 minus 0.75 is 2.75 meters. So as you can see, the distance she traveled is different from how far from her starting place she ended up, okay? Because the distance she traveled is literally how much distance she actually walked. Whereas how far was she from her starting place is just looking at the ending and the initial. So where she ended up and where she began. So we didn't really care about what happened in between here. The fourth question you were supposed to answer is, Did you ever stop? Or did Veronica ever stop? If so, when? So if you take a look at your graph, there were a couple times when she stopped where she did not travel any distance between 3 seconds and 6 seconds. So from 3 seconds and from from 3 seconds to 6 seconds. And also here at the end between about 11 seconds and 13 seconds. Okay. So during those time periods, she traveled no distance. It's just 0 here. And so she completely stopped moving. And then the last question you were supposed to answer was, did she move in only one direction? Okay. And very clearly she did not, right? And this portion of the graph is walking away, like her distance from the starting point is increasing. Then in this part of the graph, she's moving towards the motion detector. So her distance to the motion detector is decreasing. So, she switches direction here and then here again, okay? So no, right? She switched directions at certain times. Okay, so now we've analyzed the distance distance time graph. Let's talk about her average velocity. So obviously her velocity changes in certain parts of the graph. Here her velocity is this delta y over delta x. Here her velocity is 0 because she doesn't move at all. Here her velocity is negative. Let me draw that so you can see. Here her velocity is negative because she is moving back. And then here again her velocity is different. Okay, so she has different velocities at different parts of the graph. However, what we want to now examine is her average velocity. So if she went just from the starting place to, let's do yellow here, from her starting place to her ending position, and we just looked at the slope of that line. So we just draw a straight line from her initial position to her ending position. Her average velocity right here is the direct, from just going from her initial position to her ending position is a direct route. Okay, she doesn't go back then forth, she just goes straight. The slope of that direct route is her average velocity. So her average velocity, let's say we erase this whole graph. Okay, all we care about is the ending part and the beginning part. Okay, right? Then her average velocity is the slope of that direct route. So her delta y, over her delta x. Okay? So as you can see, her ending position is at about 13.5, and her initial position is at 0.75. So then her slope, so average velocity, is her delta y over delta x, which is 3.5 minus 0.75 over 13 minus 0, which is equal to 2.75 over 13 seconds, which is approximately equal to, if we put that in our calculator, it's approximately equal to 0.21 meters per second, and that would be her average velocity. Okay? So just to summarize sort of the things we saw first of all the difference between initial position So let's do some vocab here. Initial position is your location at T1, which is your starting time. Okay, usually at T equals 0. Okay, then your final position is where you end up. Okay. Your location at T2. Okay, so this is for an object moving between time T1 and T2. So T1 is when you start, T2 is when you end. Initial position is your location at T1. Your final position is your location at T2. Your displacement is your distance between your final position and your initial position. So just like in Veronica's slope graph or slope walk, you can see, I ended up at 3.5 meters. I started at 0.75 meters. So my displacement is 2.75 meters. Okay. On the other hand, your distance is, total distance is the total of all the object's motions, both forward and back. Okay, so as you can see, again, back to Veronica's slope walk, we totaled up, at least the graph, but let me draw it just so you can see Lois here. And okay. Her graph looks something like this, right? And then we totaled up, okay, look, from here to here, she traveled some distance. And then here to here, she traveled some distance again. And then from here to here, she traveled some more distance. And we added up all those distances. So we said here was all the distance that she traveled, 4.5 meters. So this right here is her total distance. So there's your difference between displacement and total distance. Displacement only cares about the beginning and the end, and then total distance cares about the whole graph, like all the distances that the object traveled. Okay? And so these are terms that are important. Make sure you know what they mean. And then we'll explore average velocity a little bit more in the next video.